Dobra. To chyba w ten sposób funkcjonuje. Ja mam tu taki sprytny podgląd YouTube'a. Okay, that was supposed to be in English. Fair enough. Hello, Greg.
Hello.
Good evening. I'll just check whether we really went live and everything is working fine on YouTube. Looks like so. Just to be double sure that everything is working and expected. This cannot be played in the background. That's weird. It's live. There are people on Facebook and there are people live, so that's fine. So we are here for fantastic frameworks and how to avoid them with Grzegorz Piwowarek, with Piwowarek, for yet another installment of Segfault Live. People telling us that we are live, which is good. This is always a frightening thing. So before I get to any form of an introduction, let's come back to the drill. We are live on YouTube. We are live on Facebook, and this is a great spot to ask questions. Whatever you type in the chat under the live stream will pop up here, and we'll be happy with Greg to address it. That's a first thing. So, and we will really appreciate questions. It doesn't mean that we don't have any. Obviously, we'll be able to talk with Greg about fantastic frameworks all evening, but that's not the whole purpose of this live. It's about you asking questions. So, Grzegorz, Greg, a few words about yourself, or shall I do it?
I can do this in a few words as you requested. So, hello, I'm Greg, and I'm a software nerd. Well, what more can I say? I've been writing code for a very long time. It's not only my job, but I really like it. And I'm really glad that we are doing this thing today, because the setup is a bit unusual. So on the one hand, it's extremely weird to do this a senior developer reacts to himself kind of 2-hour-long video. Oh. But on the other hand, the video that we'll be kind of reacting to and commenting is taken from the conference slot, which lasts 1 hour. And during 1 hour, there's quite a lot of things you need to skip because there's no way you can dig into details. So sometimes certain sentences, certain thoughts get a bit too shallow than they deserve. But that's as far as you can go during 1 hour. I remember a long time ago, I was a lot into music and a lot of different stuff. And I remember that I read an interview with Steve Vai or with some other, let's say, virtuoso guitarist. And people often come to him and have issues with, let's say, his methodology of teaching. Because, let's say, his methodology of teaching, playing guitar is, well, you need to play very slow and gradually speed up with a metronome. And naturally, the guitar study goes much further beyond that. But if you are in a guitar store and there is 1,000 people waiting in front of you to go and ask you a question, what can you answer in 20 seconds? So I feel this is sometimes what happens with conferences and 45 minutes length of speaking. You can only just inspire people, give basic clues, but the real thing, is just about hours or days of drilling experience and just starting to feel certain stuff.
What we also seen is that people are often shy or reluctant to ask questions at the end, and they just want to shout out a question in the middle of the sentence, and the conference is hardly ever give an opportunity to do that. So this is supposed to be different. So now you can just shout out your question. We will see it will delightfully comment on that. So to remind you about the drill, the talk is fantastic frameworks and how to avoid it. Greg has given that a couple of times over the past few months, so obviously you can see it over in the internet. If you haven't seen it, that's even better. You will have an opportunity. If you have seen it, you will have a few pauses in the life, which is always helpful if you want to make yourself a cup of tea. And then we've split it together with Greg, the whole talk, into, I think, 8 chapters. Each is from 3 to 8 minutes, more or less. So after each and every slot, we will have this senior developer comment on himself, which Greg was just passionate about. Yeah, that's if you like the formats, if you like the this idea, we have more of it. It's called the Segfault Masterclass, which is an online event of 5 this kind of talks, though not recycling an existing one, but a new. So under this under us, there is a banner if you would like to go there and see it for yourself. So before I start, Greg, you've been doing software for years. We worked once or twice already. Now you are working for Hazelcast, an open source company, and you are managing there, you're architecting there, or you're just cutting shit.
I'm a simple resource. And so I joined Hazelcast like in December last year, and I'm mostly working on a few new integrations, which will involve Quarkus, Hibernate second level caching, and also van replication over Solus. Plus, more or less, a bit of fixes in the IMDG itself. Okay. But if you ask me, pretty much the whole company is built from engineers. So most of us, it's very flat. And well, there's a lot of, since we build the company mostly from senior people or very, very skilled like junior people, there's a lot of freedom, and we pretty much just fix stuff. Occasionally just jumping into corporate and enterprise clients who request something to be done really fast.
So it sounds like a dream job. So though this talk is not it's not about Hazelcast. It's even not about Hazelcast at all. Am I right?
It's not about Hazelcast, but there are some references. Because, for example, the talk is titled "Fantastic Frameworks and How to Avoid Them," and some people that have no clue what Hazelcast is, they will Google it, and they will see that Hazelcast is a distributed compute something framework, and they are like, haha, I got you. Yeah, but I will clarify this at some point.
Yeah, let's not spoil everything up front. So I think we are ready for the first part. There is a small Hazelcast disclaimer, but that's the last slide. I've seen in most of the cases that a conference talk starts with a rant, and this one is no different to a certain extent. Well, without further ado, let's see. The first part is 5 minutes. 5 minutes treated as an introduction, a settling ground for what we'll be discussing later on. So enjoy, and let's get it rolling.
So I don't know if this is something that you have in your country, wherever you are watching this one. But in Poland, we have a show where, which is probably like stolen from some Western country. We have a show where the two groups of people meet, and they are supposed to guess the answers to questions that some random people responded to in some random surveys. And imagine we are doing the same kind of show, but in our IT bubble. So imagine you have two developers meeting at a random conference in the hallway track and speaking to themselves. What questions could they use? I mean, if it's a Java conference, you don't ask usually what language do you use, unless it's Kotlin or something, or one of those fancy ones. But the question that pops up quite a lot, at least on Polish conferences around my place, is that what frameworks do you use? And it's okay, but after being in a few projects out there, it's not one of the first questions I would ask, if I was supposed to interview someone about their projects, and especially if it was very successful. So I remember that long time ago when Spring and Spring Boot was challenging the Java Enterprise. I was in love. I was in love that I could use just one annotation and that would solve pretty much everything. I could have a service up and running in just a few annotations out there. But I remember like 2 years ago, well, a year ago and a half, I read the article about the Micronaut 1.0, and one of the comments resonated with me a lot. So regarding opinionated and unopinionated frameworks, I think they appeal to different types of developers. I now have 20 years of experience, and in my first few years, I loved frameworks like Spring. However, as I gained more experience, I felt I needed a framework's opinion less and less. Now I avoid them. And this resonates with me a lot, because if you play around, if you see tutorials online, if you see short pitches during conferences, this is usually not something that explores in depth the subject itself. Usually this is just a very short, very rushed way of showing how things work, usually stepping exactly through the path, the expected happy path. However, sometimes it can get a bit more difficult if you step out of the path that you are supposed to walk. So now, another question for you. I mean, I'm afraid you might not be able to respond, but there is a picture, quite a famous one. Do you know the author and the title? So obviously, that Scala programmer confronts Java project that uses Maven, Spring, and Hibernate. Salvador Dali, oil painting, 1946. Of course, that comes from the Twitter prog paintings, and it's hilarious because I see myself in there as this guy on the left with a cross. During my lifetime, I managed to kind of infiltrate multiple bubbles in our community. So I infiltrated not only Java developers, but also Scala environment. And I was able to see how both of those groups, they perceive same things, and what solutions are considered default and what are considered evil. And the interesting thing is that those bubbles are totally different. They both can deliver good software, but they have different approach to certain things. And so, for example, you won't find anything like Hibernate in Scala, and somehow they are able to survive without ORMs. And I believe that by infiltrating multiple bubbles, my third-person perspective perception of them allows me to kind of pick the best parts of all of them and deliver better software using those ideas. So, going straight to the main topic for today, which is invasive frameworks. And
let me pause for a second. I think that's double weird because this is a recording of an online conference where you just referred that to a joke that people might not respond it, and now it's kind of a second derivative that you're watching a video of yourself saying that you are not able to respond. That's Inception going too deep, I think. Anyway, first of all, we urge you to ask questions online whenever something pops into your mind. There are there are no bad questions. There are no stupid questions. They are just questions. So that will be one thing. The other, which I always have to ask, is, Greg, how often you watch yourself from the conference?
I try to do this. I try to do this so that I can just improve on things, because once you are, it's very uncomfortable for me to do that, especially in front of millions of people, when millions of people are watching, or like now. But it's necessary. I at least try to watch one or two, maybe not whole, not all of it, but at least certain parts that I'm unsure of, so that I can try and improve on. For now, for example, now I'm actually surprised. I remember that when I was giving this talk, it was late at night. I was very tired after the whole day, and I can feel that I can see that my brain is not working as usual, because my speech is very, let's say, I tend to make huge breaks between words. Okay. I believe it doesn't normally sound like that, but I remember it was a long and tough day in the middle of global pandemic.
Yeah, that's true. On the other hand, I've listened to this particular recording a few times, and I find it well spoken. It's really pleasant to listen. Anyway, you've given I think a complete run. There is not much space to add. I think you haven't touched upon PHP or JavaScript, but that will be too much, in my opinion. But let's leave it for later. You set a ground for invasive framework. So it's just magic, or it's don't spoil too much. Or maybe we just can get into that straight away.
I believe we'll get to this straight away. But what I would like to mention is that obviously, I don't think it was that much of a rant. I don't think that talk is that much of a rant, although the title might suggest it a bit. I remember a long time ago reading interview with another musician, this time with Tom Araya from Slayer. They asked him about one of the titles of the album, and the title was called "God Hates Us All." And this is an interesting thing, because Tom Araya, the vocalist of Slayer, is actually a Christian. So they asked him, why do you think that God hates everyone? And he responded, he doesn't. I mean, but it's a really good title.
Yeah, that's that one lands. So are you saying that this title was just to get accepted at the conference, or?
I wouldn't say so. I mean, I believe it would fit nice into the title of the movie it's based on, because it's from a spin-off of the Harry Potter series.
Yeah. So let's get to the to the next part. Invasive framework, as the title suggests. It'll be about 3 minutes, and approximately 3 minutes. So we'll give it a spin, and we'll get back after those 3 minutes with, I think, a first set of questions, right? So let's give it a go.
There are multiple definitions of that. So let's try to clarify what do I mean by this. And usually by invasive frameworks, I would say that I mean frameworks that are overly abusive and use a bit too much of magic. And I'm aware that many of you might say right now that there is no magic. Magic doesn't exist. It's just a piece of technology that you don't understand. And I fully agree with that. However, if you compare different technologies, you can see that some of them are relatively more complex than some others. So, for example, I believe that, for example, aspect-oriented programming aspects are a bit more complex than simple like functional programming-based solutions, or like simple design patterns like template method or execute around pattern. That's much easier to write and debug a template method than aspects. So what would I enumerate as magic? So that would be runtime reflection, class path scanning, thread locals, runtime annotation processing, and proxies and AOP in general. And naturally, all those technologies, they have their own place and they solve a lot of problems. But sometimes if we put all of them, mix them, all of them together in a bucket, it might sometimes backfire. What's interesting is that in Java community as well, if you go through, like sites of popular frameworks or enterprise solutions, usually they promise you that they will most likely solve a lot of your problems and do stuff instead of you. However, if you jump into Scala ecosystem, it's a bit different. Many libraries, they actually claim the opposite. I mean, we are not a framework. We are just a very specialized toolkit, and do whatever you want with that. And this is quite interesting to observe if you've been to one and the other. What's also quite funny is that, for example, if you have people migrating between those groups. So if Scala developers travel to Java and they see Hibernate, they get really scared. On the other hand, if you have Java developers going straight into Scala world and seeing not that many annotations, they can get confused. So it can be quite hilarious at times. However, don't get an impression that I'm like glorifying the Scala ecosystem, because they have also quite a lot of, they made some questionable design choices, and it can be messy as well.
Yeah, now we are back. I didn't unmute us. I pause it here on purpose. Great, we got I think a first question. But before we digest that one, let's. Isn't it that frameworks aren't single responsibility? Yeah, aren't single responsible. They do a lot of things, and that might be one of the source of the problems that we are experiencing.
I mean, yes and no, because there's a huge difference between. I mean, I believe that if you have a look at how people use the words framework and library, in many cases they will just substitute one with the other. But actually, there's a subtle difference between a framework and a library. Framework usually is something that it so-called puts your work into frame, which means it's something that manages your code, manages your processes, manages your servers, manages your dependency injection or something else instead of you. And a library is usually just a toolkit that you use. So it's not only you can have. I believe you could have you could apply single responsibility principle to a framework. You could have something like
huge responsibility.
Yeah, that's quite an impressive one. But it's mostly about the principle that in frameworks you give up some control to something else. Obviously, there's nothing wrong with that by itself. And I see there's already some comment coming from Jarek.
This one that you see on the screen.
Taking this definition, some languages, blah, 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 when overused can become magic invasive. Yes and no, because why do I use the word magic? Because again, as we spoke during, let me try to refer to what I just said, but on the recording, not right now. I compared the use of aspects to a simple design pattern. So obviously, this is all technology, this is all debuggable, this is all solvable. Of course, it all can get overused and abused, which can be a problem. But if you compare, as again, aspect-oriented programming, let's say you want to add logging to some method call. And if you compare this with the implementation of a template method-based, class, in a template method-based class, you have a simple call site where you can just click through your IDE and see what's happening. And in aspects, there is some magic happening that this code is getting executed around this particular method. And so if you compare side by side two different technologies, you will see that they are both, you can understand them both, but at the end of the day, some of them will be a bit more complex, a bit more surprising in a way they operate. So same with classpath scanning and other tools like that. The tool by itself, the technique is not bad, but once you can control it, but you can either cherry pick, let's say, import static methods that you use to your class, and this is pretty much deterministic. But if you, let's say, do some magic via classpath scanning and dynamic class loading, there's just way more places where things can break. And in order to make this whole presentation a bit easier for you to digest, I'm usually one of the people that try to avoid and minimize moving parts in software, in life, in pretty much in general. I tend to prefer simple solutions because they don't break. Just like with old muscle cars from USA. Yeah. It's just a piece of engine and a stick. Yeah.
So Jarek builds upon that. So magic means hard to reason about, and that's something I would kind of refer to, because when I was listening to your talk for the first time, it struck me that there is this concept of things being explicit and things being implicit. And as you denote on the journey from Java to Scala and back, that at some point we don't want to know how things work, because we just want to slap a few annotations over the code and have it working. And with time, we might get to a point that we really know how things work, and this magic just stand between us and understanding, and that's something that makes it hard to reason about, isn't it?
That's an interesting point, and I agree with that. And the other thing is, what I think why I tend to stick to more explicit solutions is that I remember when I was starting out, pretty much I matured as a developer when Spring was maturing as well, and I was really, really into it. I knew quite a lot about the framework itself. I knew all its gotchas. I knew all the conventions, and it was easy to navigate. But then I ended up in working with many different clients and big projects, microservices, where they took the freedom a bit too far. And then suddenly you realize that it's not very practical. It's not realistic to expect that you will be working only with technologies you know really well. Most likely you will be navigating between various sets of technologies, various libraries and various frameworks. And then this is where you start to appreciating stuff being explicit. Because let's say if you go to Quarkus or somewhere else, you will see that they have a bit different conventions and opinions than String. Then you jump into Hibernate, then you jump into other Axon or other magical things, and suddenly you are clueless why still things are happening. You spend days figuring that actually you should have used underscore and not a dot in some magical file that was called different than you called, because you never would assume that would make any difference.
I think this is. Yeah, go on. Sorry.
Those are the things that make me choose explicit over implicit. I mean, there is a value in being implicit. There is a value in Spring, in being able to start a Spring application using, one annotation or two, whatever. But there's a price to be paid for that. And I believe that even if you give up a bit of this implicitness, you will still have quite a lot of freedom. You will still be productive, but there could be fewer surprises along the way.
Yeah, I think you'll get into some very concrete example later during the talk. I think there's something called a principle of least astonishment. And I think Alexander has a comment which is quite relevant here. It's very detailed about aspects when you don't know which one comes first and what's the order, and you don't know it. Well, you can know it in a single implementation of aspect, and then you switch a framework or switch to a different different implementation, and things get into a different order. And this is this implicity, this is this magic that we were referring to. However, next part is coming, because on the other hand, if we don't do frameworks, we do libraries. We just do just libraries, and we just do everything by ourselves, as Spring did in the past. So if we twist it the other way around, we will be left only with libraries, and let's see how it might get on. What you say? It's about 5 minutes. 5 minutes about purely libraries. So let's go for it. Hi.
However, quite a lot of this mess can be attributed to something called like a dependency hell, which usually means just putting way too many dependencies in your project that you actually need. If you have a look at how JVM, how resolves dependencies, what happens if you have multiple same jars on classpath or multiple same versions of the same class on classpath, and then you have a look at frameworks that actually use classpath scanning and that they can auto-configure certain stuff based on how classpath gets resolved. That gets pretty scary. Actually, since Java 9, we have the JPMS, which kind of solves all of those problems. So I really await times when we won't be treating JDK 8 as the default, but we progress beyond that. So one of the good things to remember about when you develop software in general, and I have multiple backgrounds. For the vast majority of my life, I've been developing, let's say, custom enterprise solutions or maintaining in-house solutions that are supposed to be scalable, not only when it comes to performance, but they were also supposed to be scalable when it comes to how many teams are supposed to work on that, and scalable in terms of time, which means they were supposed to survive not only till the deadline in 3 months, but multiple years. So one of the good ideas to keep in mind is that you can actually try to minimize dependencies, especially in the Java world, with the zero dependencies rule being like the ultimate goal, which is of course not always achievable. But I've seen way too many projects where when I could find something like commons or common libraries or core libraries, and those core libraries you would find there a lot of interesting stuff. It was total fun for archaeologists. So you would see some Java enterprise dependencies, Springs, multiple versions, Hibernate, because someone might once need it. The sad part was that once you tried to remove something that actually seemed totally unused, some unrelated stuff in a different part of the project would suddenly break because the dependency wouldn't be there, and it would override some other dependency being present in that project and bump its version. That's not fun. However, zero dependencies can be quite hard to achieve, and sometimes might not make that even much sense. Because, for example, you probably don't want to rewrite your own, you don't want to write your own JSON from scratch, or you don't want to parse YAML by yourself. But there are tricks that you can use. So, for example, one of the simple tricks that's suboptimal, but still gives you the kind of zero dependencies feel is the application of shading. So, for example, in Hazelcast, we have pretty much like almost zero obligatory dependencies, and those that are obligatory we shade them and hide them from the public. What's more, I often see, very, very often, people adding, the whole Guava or whole Apache utils only to use, one static method like is blank on a string from string utils. In this case, you can apply manual shading. You can pretty much copy and paste this piece of a code. Well, of course, according to the license and giving proper credit. You can manually put it in your project and avoid extra dependency in your project. The idea is novel, but it can be hard to enforce at times. But luckily, we have stuff like ArcUnit. So you have a tool that actually allows you to enforce certain design architectural decisions in your project. So, for example, I have a few my open source projects on my own, and that works pretty fine because you can enforce all of those decisions pretty much by having a few single unit tests. So definitely check this one out. Even if you don't go for zero dependencies, or even if you don't try to minimize them, that's something really worth looking at because it basically replaces an architect at times in your project.
I want to pause here, not because you just said that you can replace an architect with a set of tests, but I'll kind of relate to that. You said a lot about no dependency, zero dependency, inlining code, and making sure that the code is properly inlined. That's all fine. However, I have a question on that because when you were just talking about that, it reminded me or just gave me this idea that isn't the dependency have a function of maturity of the standard library? So, or our programmer's awareness of the standard library. If you have a language that has a very powerful standard library, you don't have libraries as left part that you have in Node.js. Though Node ecosystem standard library is not that bad. What's your view? Like in Java, the standard library is pretty powerful to a certain extent.
In Java, the standard library is pretty powerful, but if you start adding, if you go for frameworks, usually, I mean, standard library is pretty powerful, but I challenge you to write a fully production-ready microservice using only standard library itself.
Yeah, that's the second part of my question. Should I write always my own JSON parsing and HTTP client, though in the latest Java you have an HTTP client? However, in my opinion, it's not really production ready. We can get to that later on, and a few others. Yeah. So where's the balance? Where's the balance?
So there are a few things to consider here. So first things first. Once we spoke about magic, class path scanning, and all those things together, dependency hazelcast by itself doesn't cause that much of a trouble because it's just a lot of jars in the class path. However, those dependencies sometimes have dependencies. These dependencies sometimes can be in various different versions that would need to be resolved somehow. If you have a build tool, that's one problem less to worry about because the build tool won't allow you to put multiple jars in a class path together, but will just, let's say, use just the newest version, just use only one. But if your tool that relies on that, let's say, violates the principle of least astonishment, reads your class path and figures out that it has quite a lot of jars, quite a lot of classes to discover, auto-wire, auto-configure, this can get problematic at times because from time to time you will figure out that, for example, by accident, well, you are not using RabbitMQ in production, but you have RabbitMQ client actually auto-wiring and trying to connect to some default port to your local host and somewhere. Or sometimes you go to production on your H2. This is what happened to me personally by accident. Or you go to production, and your transactional annotation doesn't work because for some reason the annotation processor is not on the class path, wasn't found, or was overridden by something else. And JVM didn't really tell you that if the annotation, if there are no classes backing annotation, that something wrong happened. They just ignore it. So that's the one part. So the problem is itself if you take into consideration those few things. Second part is that as someone that I create tools, I work for a company that creates tools, and usually we want to be as the lowest possible amount of inconvenience to users. And if we know if the other users are using frameworks that rely on class path scanning and stuff, so we should probably try to minimize the number of things that could break. And this is what you can do using by minimizing dependencies or just shading them. And your next question was about, should we rewrite everything? No, of course not. This is not about not invented here syndrome, because of course there's no point. And if you've been paying attention, you would see that I used hazelcast as an example of a tool that's actually dependency free. The funny thing is, if you go in there, you will see that it's not really dependency free. It has quite a lot of dependencies. And there's actually really no point in writing your own YAML parser. There's really no point in writing your own JSON processing engine unless you really have some extra value that you can add to it. But what's important is that we shouldn't expose it unwillingly to our users. So for example, hazelcast itself, it uses YAML parser to parse configuration. But if someone adds a hazelcast to their class path, they probably don't want to be blessed with the convenience of having a YAML parser on their class path being ready out of the use just before they added hazelcast. And this is where it goes into that. This is where we arrive at the topic of modularization and coherence and trying to keep stuff, and encapsulation, and not leaking out stuff that isn't absolutely necessary for us to go. So I'm not. Yeah.
Because you mentioned in the talk about Java module system, which probably might or might not be one of the ways to mitigate that, isn't it?
Yes, it will help a lot, because if you package your applications in the modules, you can actually restrict other modules from seeing some internals of the module itself. So it won't auto-discover classes that are in there. It will see only what you explicitly wanted to export. And this is how you can narrow the surface area. You can hide all the stuff that you don't want to share with other stuff, with other programs. And I really believe that actually encapsulation and just exposing only stuff that you want is one of the keys to being successful in at least in Java, in the Java world. You can save so many problems by hiding unwanted stuff from other people and exposing only the minimal area, a minimal API or minimal area that people can interact with. This is probably one of the biggest, let's say, advice that I would give to people. And the same here. Don't rewrite don't reinvent the wheel, but try to hide it if possible. And this is a universal advice. You can apply it in many different languages. But in Java, we have, let's say, limited tools to do that. Because JPMS, on the one hand, is not, well, we are still on Java 8 everywhere. So we are not willing to ship libraries that depend on something more than Java 8. So this is kind of out of the question for now. On the other hand, we can shade stuff. We can just not put or we can be just very resourceful when it comes to why are we adding things. I've seen so many people adding Guava only to, convert 3 lines into one.
Yeah, to do some basic string operations. But when you mentioned shading, what's your strategy for shading? For example, in hazelcast is kind of a very particular example that you just bump the whole dependency into com.hazelcast.external.com.guava, or you do it in a slightly more fancy way, or you just cherry pick those tiny bits that you really need? What would be your strategy for that?
Okay, so just in case, let's recall what shading is. Shading essentially means taking a dependency and not making it a dependency, just repackaging into the source code of your application. And when it comes to hazelcast, we have a mix of those two things. So the most common way, if you have Gradle or you use Maven, you can use a plugin that will effectively just repackage, let's say, your cherry-picked dependencies and repackage into another package called, let's say, something internal, and say Guava something else. And in this way, if some library, some framework, or someone else tries to discover the class that they would normally look for from Guava, they won't find it, because guess what? That's a different package now. That's a different class. That doesn't work always, because it will only work if those APIs are actually, they don't leak out via public APIs. Imagine you have a JSON processor or something like that, and somehow you want to expose it in public API. Suddenly, it's no longer com something Jackson, but it's com hazelcast internal Jackson something. So obviously that won't work, won't compile. And this is a common mistake and common problem I've seen. So that's not always feasible. Another way, a very simple one, is that if you want, let's say, a left pad, instead of implementation, instead of adding the whole package, you just copy and paste the small piece to your utils and say that it comes from left pad and give proper credits, which is, to be honest, much easier than just repackaging the whole jar only to get, just those 3 lines of code. Okay. I'm not sure if I answered your question.
Yeah, well, totally. Just there's always, as you say, it's always one versus another. It's always a discussion of drawbacks and possibilities. But yes, as you're saying, it's one of the it's totally one of the approaches. There are some comments about how your dependency hell can effectively forbid you testing your application because things just explode. And I think we can relate to that only with a long pause of sadness that somebody is really forced to live in those kind of problems. And yes. And the other one is for Jarek. Jarek, I think, is becoming very great. It's fun tonight. If you isn't it that if you overdose with the shading, you might get problems elsewhere as you start putting far too much stuff?
Obviously, of course, but what Jarek says, it's like he said about having copies of the same class. Obviously, that's a pollution, because then you have, but ideally, if you shade, you want to avoid having same class. You want to have only one class just hidden from the outside world so that it can't find it. Then it's not a problem anymore.
So that one is answered, Jarek. Shall we go on? The next part is about 8 minutes. You continue on libraries versus frameworks, right? And,
I don't remember.
Well, I do remember. And yeah, about how you can approach development when you have a framework or when you have a set of libraries, and how things differ. So I'll give it a go.
Okay, but at least in Poland, it is in Polish language. Many people kind of use frameworks and libraries, the word, as replacements, but as synonyms. But that's not exactly the same. So the difference between framework and library is that the framework is something that puts work into a frame. In the context of IT and programming, it means usually that you have the base of your project is a framework, and you kind of let go the control of your classes, of when you instantiate them, when you manage them, you gave it up. You give it all away to the framework itself for you to manage. So as Spring, for example, or Quarkus, it's a good example of that, because at some point in time, you need to say, okay, Spring, you do your stuff, and I'm no longer instantiating my own classes. When it comes to libraries, it's a bit the opposite. It's like your code is in the center, and library is something that you use whenever you want or not. What makes a huge difference is that, for example, imagine you have a project where you really like some feature from Spring, but you at the same time you like this really cool feature from Quarkus and Micronaut. Putting them together can be problematic at times, because usually only one of them wants to own your code. And when it comes to libraries, it's the opposite. Since those are just something that you can plug into your project, you control it. So usually it's not a problem to have multiple libraries in your project. It's perfectly fine to put Hibernate and, let's say, JDBI or something else that acts as for the sake of persistence. What's interesting is that frameworks exist beyond software. So probably you worked in Agile, as in Scrum especially. Scrum is a form of framework, which says you plan on Mondays, you retro on Fridays, you wake up, you stand up at 10 a.m. and you'll be successful. Well, I'm being sarcastic, but that's oversimplifying. That's how it works. The good thing about this is this: once you meet and you evaluate how it works, and if it doesn't work for you, you say, okay, we are not doing retros on Fridays, but on Thursdays, and you can change that. But it would become problematic if you were not able to do this. And I've seen companies adopting Scrum by the book, and it felt even more rigid than before. So, for example, another types of frameworks is franchises. Imagine you want to open your own Whole Foods or Walmart. It's all going perfectly fine until you actually don't want to change something. They provide you, they give you the business plans. They find a place where you can run your store. They give you logos and everything, even help you with hiring crew. And imagine you want to change the name of the store or colors, let's say, or the color in the McDonald's logo. That's a no-go. And that's an example of frameworks where they can become limiting. So it's very important to understand the trade-offs and consciously opt in or opt out from some of them. So just a few notes about frameworks and some aspects that you have not probably thought about. So a very obvious thing: they take time to learn and update quickly. Our industry is speeding at an insane pace. So those technologies outdate very quickly, and that's okay, because we are making huge progress. But we have a limited time during the day. We have only 24 hours. Well, now, especially when we are all quarantined, it might feel like we have a bit more, but it's still 24. And in order to be very proficient in an opinionated framework, you need to learn framework's opinion. You need to learn how it works. Otherwise, you will be struggling long term. So you need to learn how your properties files are structured. You need to learn how to structure your code. You need to learn where to put annotations, where to skip constructors, and all stuff like that. The problem is that those opinions can change, that will change very quickly. And if it changes, you need to kind of relearn all of that. And if you don't spend time on doing this, that's actually where you can be even less productive, because you still keep in mind the old ways of doing things. And another aspect is that once you commit to a certain framework, once you use your domain class, let your domain classes inherit from some base classes from some framework, and pollute your domain, your like domain with all the annotations and methods that were inherited from framework classes. Suddenly, it's very hard to kind of move away once you figure out that we no longer need this one. There are better alternatives on the market. And if you don't keep up with the release cycle, with the new releases coming over and over, you might not be even able to migrate to the newer version of your framework which you use. And then you probably might need to pay quite a lot of money for someone to backport security and bug fixes for you, which can be expensive. The next thing is that sometimes, I mean, in most cases, if you bring this big, huge solution that's supposed to solve all your problems, it often does, but it also brings quite a lot of stuff that it solves the problem that you don't have and brings a lot of stuff that you don't really use, which can increase the complexity, weight of the project. It can contribute to the long startup time, or they just bigger memory usage than you would expect. Another aspect of frameworks and libraries and the industry going very fast is that they go out of fashion and then get abandoned. So imagine that we now on the market have a few competitors that are trying to, let's say, take over. They are trying to actively take over where Spring is at the moment. And if they successfully do this, you might need to forget what Spring was doing and how they were doing this, because there are new things, there are new frameworks, new libraries with their own opinions and their own ways of doing things. So that's another aspect that you need to take into consideration once you make the conscious choice of opting in or out from certain technology. So the same problem is that you need to keep up with them, and if you end up stepping out of the happy path, you might need some expert help, which is again very expensive. And now, at some point, usually someone points out, this is usually a moment where someone points out to Google's what hazelcast is. And on Wikipedia, they see that, Greg, but are you doing a framework as well? Well,
I'll posit you referred to that already. The thing I would like to mention now, we kind of describe how framework owes you, is that, well, one thing is, if you, and I'm now referring to the audience, have any questions or concerns or would like to ping back or anything Greg has said or saying, I encourage you to ask questions in the comments section. And now, my question is you refer to quite a lot of disadvantages of being owned by the framework to a certain extent, but on the other hand, is this relevant anymore when you just bang new services just one after another in your microservice environment with just polyglot everything, and well, you try this framework and after some time you try the other, so is it still that much relevant? Or
that's actually the core of the problem, because suddenly you end up, it's very, if you bought in the domain of the promise of microservices, where you can be poly framework, polyglot, poly everything, suddenly it's very tempting to have one service written in Go, in their let's say Go specific frameworks. Then you write something in Java in Spring, and then you figure out, oh, let's deploy this one with Quarkus on GraalVM native image, and then something else. Suddenly it turns out that if we have a stack that's heterogeneous, if we don't take into consideration all of that stuff, it can backfire. And that's what I'm trying to, that's the message I'm trying to send here. Because if you look at developers, they watch conference talks, they want to try those things out, but quite often I see there's a lack in long-term vision, long-term thinking, that maybe adding one more vendor with one more huge framework with their own solution will lead to bigger problems along the way. Maybe not now, once the framework and the tool is fresh and cool, but maybe in 2 years from now, once it won't be that cool, maybe it will be already legacy. Some bugs will resurface, but the migration to the new stuff won't be possible anymore. So, of course, I'm not trying to say the frameworks are bad here. I'm trying to increase the awareness that there are downsides that you need to take into consideration if you are thinking in a long term and not only, in a time span of a few weeks.
Fair enough. Fair enough. There are already some questions and solutions coming in the comment section. I'm not posting them intentionally, and I am now referring to Alexander's question about certain way of architecture application. That's because I don't want to spoil some part of Greg's talk later.
So let's skip Jarek's comment as well, because it's kind of related.
Oh, okay, I focus on that. Yes, so it's not that we are ignoring you, definitely.
We aren't?
No, I like those people who are watching us, especially that they cannot throw anything at us as it's on the conferences because we are online, and it's just a different greatness. So you're coming next with a very particular example of frameworks in the database world or in the application to database relationship. Any spoilers on that, or we just get into a 6
Let's just go and see.
Yeah, so another part where Greg takes it by example, what he just said in general, is 6 minutes about frameworks and databases. So you might expect, what technology we will be referring to. So now let me just unmute you, and we can
go on. That is.
So,
but another thing that people mention usually is the question. So, Greg, you don't like frameworks, we get it, but wouldn't you like to focus on real problems and let authors do the boring parts? And yes, of course, I'd like to do this, but all non-trivial abstractions to some degree are leaky. And that's an article from 18 years ago by Grzegorz Polski. If there was a solution that solves my problems in the way I need them to be solved and the way I would solve them, I would totally opt in. But the problem is that's not usually the case. Usually you need to make trade-offs and you need to accept the parts that you don't like in order to benefit from those that you like. So in some cases, it's worth thinking about, because if the high-level abstractions are leaky, it means that you can't really rely on them, but you still need to understand what's happening underneath those technologies. So with this limited time that you have per day, you still spend time learning someone's abstraction and not the underlying technology. And now it's a question for you. What do you think would be more beneficial for you? To learn another set of rules and opinions, or maybe learn the SQL really, really well? This is how we get to the ORMs and JPA and Hibernate, for example, which works really good for certain use cases, but it brings a lot of trouble in the projects I've seen, mostly because people don't understand how JPA works. So if you see the tutorials that are available online, in many cases, you will see that they are oversimplified, and that's okay because those are tutorials. But people often apply those ideas without any afterthought. So what I see quite often is that you take your core domain classes and you put all over them a lot of JP and Hibernate annotations. And well, this is only one class and it was a tutorial, so you also put the Jackson annotations in there because, well, it's a user, you can store it, you can persist it, you can convert it to JSON as well. And this is when it starts to hurt at some point in time. So as long as the model is simple and graspable, and we are on the happy path, that works really cool. But if you take it to an extreme, sometimes it can become, well, really overwhelming. And annotations can actually form some form of meta language inbuilt in your language, which is really hard to track and debug at times. So, for example, if you are looking into ORMs and persistence layer, SQL is great. It's completely self-sufficient. It's fully declarative. But there's a problem, because if you want to, let's say, not use JPA and just use SQL with, I forgot the name of JDBC. There's just a lot of string concatenation. There's just a lot of just stitching strings together, which is terrible, let's be honest. But we have tools that solve those problems, only those problems, not all of them. So for example, SQL, the lack of type safety in SQL is solved by Jook, J-O-O-Q, where it doesn't really enforce anything on the application, but you can use it to build your persistence layer or just to generate SQLs. If you are into Kotlin, there's kind of similar idea emerged in there with the Kotlin exposed, which allows you to do the same. You don't need to go for this huge JPA Hibernate project. You have an idiomatic solution, Kotlin exposed, where you again effectively it just lets you write SQL using type-safe builders. And if you are using Spring framework, there's a really cool solution that's not getting enough attention, I believe. And you have access to it pretty much in every Spring project, which is a JDBC template, which makes persistence really, really easy. And this is old and good JDBC, just on steroids, which makes it much easier to use. Without pretty much all the pains of the classic JDBC are gone here. You still might need to manually stitch some strings, but the mapping is really, really easy. So at the end of the day, you write a bit of boilerplate code that allows you to where you take the result set and convert it into an object by hand. Same with when writing inserts. But at the end of the day, that's a very simple code that is really hard to break. And if you opt into Hibernate, you need to understand how it works. You need to understand the dirty checking, where the objects are attached, entities are attached or detached. And it has certain benefits. But when it comes to tracking which objects come from which session, if they are attached or detached, you don't need to worry about this, all of that. You convert it manually from a result set, you get your object and it's done. You forget about all the problems related to, let's say, those Hibernate proxies circling around your project. So Hibernate naturally has a lot of advantages, but that's a really cool one that I really appreciate. Things being simple and not really breaking, like the muscle cars of America and 80s.
I'll pause it here.
I said this. I made the same joke. Yeah.
Twice. Yeah, that's the disadvantage of like senior developing, watching himself and judging himself. Gavin King, the author of Hibernate, said, I think at some point, that Hibernate is a tool, but it's not a tool for everything. And people probably didn't get into that part of README and start abuse it. But you've started with people throwing annotations on the top of the code, like from all the layers, Reactive, Eric's web, RESTful, and database. But on the other hand, that's how it was sold to us, and all the developers, evangelists, presentations, and all the tutorials just throw a bunch of stuff and don't think about it. So that used to be a definition of easy and unmaintainable, wasn't it?
Was it? But easy doesn't mean simple. At the same time, it's all very easy. But if you actually try to figure out what's going on underneath, that's quite complex. And just for the record, I'm not against all annotations. I'm referring especially to runtime annotation processing. If you do compile time annotation processing, that's somehow more predictable than doing this at runtime. So it's not that terrible. But again, I'm not challenging the reason for Hibernate's existence. I challenge its becoming the default that whole Java bubble starts with. Like even people having very, very simple projects, they start with Hibernate. And I think there are better alternatives for most use cases. I mean, personally, I still use Hibernate. There are contexts where it makes sense. I even maintain a library that's an integration for Hibernate, But maybe the reason that makes me understand what's inside and make me scared of it at the same time. So, for example, as I said, during the recording, if you are already into Spring, if you already have Spring data and all that stuff, you most likely have on your class path something called JDBC template, which is much easier to use, much simpler, and there's a huge difference when it comes to the number of moving parts. I mean, there are no moving parts in there. It's just JDBC. You write object, but you write new. You make result set dot get long, and that's all. But I know we are all new developers. It's too simple for us to just type what get long like animals and new. I will just write an annotation processor that wires up dynamically, with something on the class path pops up, sets up the session, tracks object state, and then automatically remaps it into the database schema. Yes, that's what we want to do.
I think that like one of the heuristics for successful usage of ORMs is that when you start fiddling with string concatenation to make your SQL dynamic, that's the moment when you start scratch your head, should scratch your head and think whether I'm doing something totally wrong or I'm using a totally wrong tool. And then for example in ORM shines, whereas
so for example, when you have if you are working, I would assume that it happens a lot in DDD-driven projects with huge object graphs. That can be really painful to actually save and read from the database. If executed correctly, Hibernate can help a lot with that, and not building really huge nested string concatenations and subqueries. But there is one thing that I would always advise to everyone. Start schema first. Don't let Hibernate generate the schema of your database, because this is usually just some funky stuff.
Yeah, that's true. You mentioned also another tool when we are in the area of databases, which is Juke. But then I just whether you can refer or put your opinion on, because on one hand you have runtime processing, runtime annotation processing, and Hibernate, and all of the magic that can happen on runtime. But on the other hand, with Juke, you have code generations, which is for some people considered equally evil, that you get a bunch of code auto-generate into your project, and then you use it. So drawbacks and decisions, again.
I agree. However, there are different types of code generation. So I treat it as a downside that actually Juke needs to generate code for me to use. But since the database schemas are a pretty complete descriptions of what's in there. So the code that's generated is pretty deterministic and predictable. Well, of course, over the years, they evened out the bugs in Juke, so it's somehow acceptable. But if you don't like it, and you, for example, work with Kotlin, Xpods have an option for you to avoid that. You need to then do it, of course, by yourself. This code written by you, and you avoid putting some random code in your, auto-generated code in your project. But it's a trade-off.
We might get a bit Juke oriented now, but for example, there was a comment that Juke will require a database running somewhere.
Yeah, that's a very good point.
Though I would like to challenge that, because I've heard of a project that a friend of mine heard of, that they were doing Juke generation based on flyweight something, and a little bit intertwinkled but faster. Anyway, yes, that's a valid point. But on the other hand, Juke is database dependent, so you have to have database running.
Personally, I really like Juke, but if for most simple projects, usually I would gravitate towards JDBI or JDBC template, because that's I don't need actually more in most cases. That's all I need.
Shall we go to the next part? Because you are doing exactly the same what you did with databases, you are doing with frameworks, and it's springtime, isn't it? More or less. For the record, neither Greg nor myself are very much against Spring. I personally use it on my daily basis, to the extent that, on my daily basis, like all the services that I'm having at the moment under my jurisdiction are Spring-based. So it's an example, just to make sure. And same was Hibernate.
I still use Spring. Not that much recently, but I consider Spring, like I've been using it for most of my services anyway. But still, even if, despite, it doesn't matter if I like the tool or not, if I use it or not, we need to figure out the best ways of working with that.
Yeah,
and those are like small practices that you figure out over time, how to squeeze the most without like falling for the bad parts.
Yeah, that's true. And this part focuses on quite a few good ideas how not to get eaten by framework, but use it for your own sake. So let's go. Another one is approximately 7 minutes 20, and we'll get back into the spring discussion. So
from Jason,
here you go.
Spring is also a great example of great framework that you can improve the experience of working with just by remembering a few good ideas. So I remember a long time ago, tutorials all around the place. They were praising Spring and annotation-based config because it's so easy. They would normally just put a non-final field into some random class, put an auto-wired annotation on this, and look, it injects and it works. And yes, it works, but even the Spring team long time ago realized that it actually has a problem, that there are trade-offs. It introduces a tight coupling with the framework, and the most sad part is that it forces weak encapsulation and mutability. Because maybe your fields, it's a good idea to keep them non-mutable, but in order for the injection to work when you put an annotation on a field, it needs to be mutable. It can't be final. So already there's a trade-off. You need to give up immutability for the sake of dependency injection. Another thing is there is no clear constructor. So that's not that obvious how you create and how you initialize such class and tests. Imagine you get a class to work with from your friend. In such case, it's not really obvious, because if you instantiate it, you create it using a default constructor, then you need to set the field manually And then it turns out there's this post construct method that you need to invoke manually. That's a lot of things to remember. And all those things can be actually encapsulated and exposed through the public API so that people that consume those classes, they are not burdened with thinking about all of that. So a very simple idea is to opt in constructor-based injection, which is a huge improvement because now we have a public API for instantiating our classes. So as you can see here, you know that you can create a facade using, and it requires one dependency, which is called the full service. So now, if you want to create an instance of that, you are forced to provide this dependency once you try to instantiate it, which is great. But you still have this post construct method, which you need to call manually, which is non-ideal. So luckily, in the newest versions of Springs, since already a few years, you don't really need to put auto wires in your constructor because it can discover it by itself. But we still have this post-construct method being called here. There are valid reasons for having post-construct methods in your Spring applications. But this is probably not this one. This is a simple method, simple plain method call that does actually not much inside. So in such cases, maybe you don't need the post construct and you can move the instantiation straight to the constructor. And now once you move this class, you give it someone to play around with. It's not a problem because you instantiate it using the public API and it's ready to use, which is great. But wait, what? It seems like the config disappeared because we have no annotations whatsoever. And this is another really underestimated Spring feature, which is called, well, Java-based configuration, which allows you to keep all the related Spring configuration in one configuration class and manually instantiate all the classes that you actually need, which is really convenient because in this way, you don't make any compromises for the sake of dependency injection framework, but you reuse the public APIs of those classes. So full service and full facade, they both are instantiated manually using public APIs and then registered as beans, which allows to keep Spring in one spot, and it doesn't sneak into domain classes and other ones. So if you want to give up and replace Spring with something else, or not have a dependency injection framework at all, you just drop that class, and that's all. You can start wiring it up again by yourself. Another idea is that sometimes it might be even easier. You don't need to register all the classes as beans. Of course, there are valid scenarios if you want the magic transactions and proxy metrics and the proxy magic to work. You need to do this. But if you have a simple services, simple plain Java classes that don't rely on this kind of magic, remember that you can just instantiate it by yourself straight and not register it as beans. Spring will have a bit of less work to do as well. So we arrive to the conclusion where we have the same framework used in an invasive and not so invasive way. And the bad news is that it's up to us to figure out the ways of doing this in a non-invasive way. That's not a universal concept that you can apply to all the frameworks. It's up to us to analyze how they look like, how they work, what are their ups and downs, where are the trade-offs, and up to us to try to minimize the impact in order to get long-term maintainability. Naturally, maybe your context is different. Maybe your project is supposed to be shipped in 3 months, and someone else will be maintaining it. Then you have different contexts and different choices to be made. Another thing that I really like to use is that instead of magical annotation, quite a lot of stuff can be replaced using a composition and simple delegation. So, for example, imagine that you want to apply caching to your to some of your classes, or imagine you want to configure interceptors or anything like this, like in Axon. That's something that you don't really need to do using annotations. It's not really a lot of code to write if you don't want to use that at all. So, for example, introducing caching to your, let's say, user session repository is just implementing the same interface, putting the original implementation in there, just caching it manually. The cool part about this is that if you want to test all of that, you don't need to wire some magical framework that will wire up all the context. It's all available just for unit testing because it's you who control the caching, not some annotation processor that needs to interpret the caching annotations on your classes.
I will pause it here. You might have heard timer. That helps me manage the presentation. I have a feeling that what you are talking about is pretty much programming one-on-one and design patterns one-on-one, which we kind of get shaded through all this frameworkish stuff, and we've totally forgotten, isn't it?
Yes, it is. I believe that classical training that's what quite a lot of us is missing, at least a brief recall of the basic principles. It's very easy to forget about all of that if you are like bombarded with new fancy toys that you want to try out. But I believe I'm in a place that I'm often expected to generally find the biggest value thing in a long horizon, and I should prioritize long-term benefits over short-term personal goals of me, for example, enjoying a new tool, framework, or something getting magically done fast. And I believe that like recalling the basics is the best way to do that. And the same way with frameworks. If you want to stay independent, and if you want to avoid excessive coupling, you need to figure out what your application is, where are the boundaries, and where you hand over the work to the framework or whatever tool you use. So personally, what I like to do is that my application, in most cases, is just as much as possible would be enclosed in a simple Java class that you could start with new and call some method on that. And once the whole application, the whole logic is in there, I can expose some of those methods through, let's say, Spring Web and web controllers. Then I can write special integrations that help me, let's say, interact with a database or somewhere else. And this is effectively what's called a clean architecture, hexagonal architecture. It probably used to have a few other names along the way, while it was kept being reinvented on and on all over again.
Yeah. These are these comments that we mentioned earlier on, and we can just reveal it. Yes, architecture and thinking through what you are supposed to do. You touch upon constructors are being the best agnostic dependency injection mechanism. Yes, exactly. So it's a matter.
Actually, the common misconception is that dependency injection is not actually, having those big containers, with objects just being in there and some magical hand putting them, stitching them back together. Dependency injection is effectively just accepting a dependency from outside and not creating it inside an object itself. In its very core.
Yeah, and the thing is just understand it not only for my core domain object, but also for parts of infrastructure, and it will make my life much harder. So kind of every new date or every static initiation inside of my business logic class is a smell, and I should think how I'm gonna test it, how I'm gonna
power mock.
Get rid of it. Well, not only power mock, Mockito in the latest version, I think, has a static support. At least I've seen.
Oh, cool.
Tweet. Yeah, not cool. No, not cool. But yeah, that's so. Like on one hand, tooling improves to make other people's life less miserable, but on the other hand, some basic practices help us mitigate. So Jarek has another comment in here that the solution isn't solution to build your code in a way that you don't depend on a framework or anything else. You have adapters layers which makes your code work with the framework. It is an extra effort, but makes easier to change the framework. So that's kind of hexagonal architecture in 2 sentences, right?
Yes, pretty much. Yeah. So at the end of the day, it boils down to making just paying attention how much what you share with the framework, with the tools, and if this is intentional or if it's really needed.
Before I get to the one of the last part that we would like to explore further, which is you talking about the clean or hexagonal architecture with some examples, let me pose a bit on the frameworks, because on one hand you said that we are talking changing frameworks. Hardly ever anyone does that. That's one thing. On the other, we say that people jump from framework to framework. They jump from Spring to Ratpack to Quarkus to Spark Java to something else and then back. But they are still kind of in the same source. It's all, most of the time, HTTP-based, servlet-based underneath, and so on and so forth. And we say that's all the same. But then a paradigm shift, and for example, people start using reactive, and things get slightly more convoluted, aren't they? And it isn't that easy to change a framework. How it's working? Asking for
So first things first. I mean, of course, all those ideas of hexagonal architecture, clean architecture, they are not supposed to encourage, switching frameworks, all the time. Even if you can, it doesn't mean you should. But even if you keep those ideas in mind, at the end of the day, you get something that's way easier to test, way faster to test. So, for example, imagine try to test, a Spring web controller with a lot of logic that's inside the controller itself. Then probably you either you start up some huge integration test where the whole application is running, or you play around with some mocked web layer, which are tools that given by Spring to you. But if you, for example, keep all the logic, within the boundaries of your application that's framework class, and you just expose it for the framework to expose it further via web controllers, then it's not a problem. You can test the whole logic very fast, pretty much in memory, on your simple Java code, and then only test it if it plays well with integrates well with the Spring Web, for example. That's much easier, much faster to test in the long term, I believe.
But on the other hand, that requires, I don't want to say more effort, but it requires more knowledge, more experience to understand how.
That's why this presentation is here. That's why we're doing this. Because at the end of the day, sometimes if you jump into a project that's a pile of mess, it turns out that someone at some point will tell you, oh, is it really worth redoing all of that? But the point is that if you need to redo all of it, it means that some of the stuff could have been avoided by making simple choices where the cost wasn't really significant. Long time, like a few years back then. Also, one important thing that I forgot to mention earlier is that I'm speaking a lot about decoupling being bad and all this stuff. But imagine having your application or architecture fully decoupled from everything. That wouldn't be very practical, being like achieving 100% decoupling. That's probably not even possible. Imagine that at some point you figure it's not the point that you need to be decoupled from everything, because at some point you land in a very weird area where you figure out, oh, that's a Java string. That's too much coupling to the Java primitive type. I mean, to the Java type. A string actually is a supplier of bytes, right? In the very core, you can go in a really bad in a very bad place if you keep thinking along this way. So I don't know your systems. I don't know your applications. You need to. I'm here for you to show you how those ideas look like, but it's your context. We're going to figure out where it makes sense. If you feel that replacing all strings with byte suppliers of byte arrays is a really bad idea, in your context, it might actually be. So don't just suddenly rewrite everything to the clean architecture or something else. I've never seen 100% clean architecture.
I think we have to accept certain parts and understand like what's moving. That's something you pointed out earlier on in this talk, that we understand what is moving, what are the moving parts, and we abstract them. And if something is not moving part, we don't abstract them. Say quite often when the whole Eric's Java, Reactor, Eric's whatever start coming into play, people were saying, okay, but now all my domain logic is mono and flux or observable and single. And it used to be clean. Well, it wasn't clean until it was all about list of something. And we just accepted that list is a part of our word. Now it's list and something else. And we say it's part of us. And then we move on to a clean architecture. Isn't it like that?
That's a really interesting point, because the reactive stuff, this is something that exists somewhere. That's kind of exists somewhere on the boundary. It mixes infrastructure. It mixes a bit of infrastructure into your logic, into your types, so you can't be fully decoupled from what lies beneath. And it's a very good example where actually it's not fully possible. It's just you accept that this is what it is. This is the part of the clean stuff. Although you don't really need to, because since JDK 9, you have the reactive streams, which is a set of interfaces which kind of unify all the approach. So technically, you can have this expressed using the core libraries. Yeah.
I think it's subscriber, not observable, neither flux, but I don't remember if there is a mono or single equivalent for subscriber.
I don't remember. Yeah, but I know that you can, using those interfaces, you can make it kind of, you can express the same intent, but without relying on the fact. If you are working with Eric's Java Project Reactor or your homemade reactive framework, whatever.
Yeah, that's what we do. Homemade reactive frameworks.
That's why I mentioned this. Is that if you go online and see, most presentations about reactive streams in Java 9, there are people actually trying to implement those interfaces and show how it works. I mean, it's a very good exercise by itself to do that. But I believe that at least some of them actually miss the important part, that you are not supposed to implement it.
I think
yeah.
Konrad Molavsky once at his presentation, Konrad was the co-author of reactive streams specification. Once said that, yeah, you're not supposed to implement those. These are to be implemented by the framework, and you can play with it, obviously, as you can play with doing your own JDBC driver. But yeah, that might not be the best idea. So let's dive into clean architecture. Which will be another 6.5 minutes journey around hexagonal approaches and clean architecture. So let's go.
If you ever heard about hexagonal or clean architecture, those are kind of very, very similar concepts, just advocated by two different people. Hexagonal architecture is it's a bit theoretical idea of writing your applications in such a way that in the center of your systems there is a domain, which is framework and library-less, which is just a clean code representing the pure domain. But this domain exposes certain plugs outside, where you can easily plug in your persistence, HTTP clients, and whatever else is replaceable. Why I'm saying it's theoretical? Because it's really, really hard to write a whole system in a pure hexagonal manner. But it's a very useful idea to keep in mind, to remember about once designing your systems. So I have one story to tell you about playing with Axon, RabbitMQ, and Kafka. A lot of this information might be, by the way, outdated because it's a story from the Axon 2 times, and now it's Axon 4. But it works really fine. So in one of the previous companies I worked for, we had a really huge system consisting of over 150 services. And after some time, we figured out that RabbitMQ as a communication medium doesn't really scale that well for us because there was a lot of traffic going through. And since the system was event sourced and utilized CQRS a lot, so there was a lot of events circling around the system. It turned out that the RabbitMQ is a potential problem. It's a potential single point of failure. And we try to do something with that. At that point in time, we're considering going into Kafka or something else. And adoption of a certain framework allowed us to write a very easy way of handling certain events from RabbitMQ. So our thought was, okay, so let's just get the Axon Kafka module and make it and try it out with Kafka. So we go to the Axon repository, and this is where the surprise comes in. There is no Axon Kafka module. I mean, there was not at this time. There is not. It exists now, naturally. And now we have a problem because our system was based on Axon. There were many services communicating through Axon, which treats RabbitMQ as the first-class citizen. And there is no way you can kind of opt in and plug in whatever else you wanted at that time. So we had a few choices, either to run away from Axon, but it wasn't really feasible to run away from 100 services that used Axon. Another option was to actually try to contribute to Axon and contribute to the new Axon Kafka module. And this is how it ended up with one of our engineers actually contributing the Axon Kafka module, working for a few months on that. At the end of the day, we never managed to migrate to Kafka. Well, maybe they did. I don't know anymore. I don't know at this point in time. But the work spent on the Axon Kafka module was significant. It was a few months of work. But at some point in time, we decided to take a different approach and managed to solve the problem in, I think, under 6 hours. And the idea was to actually not rely on the framework. And I want to show you that it's not that much work as you might expect. So, for example, if you want to handle events coming through the RabbitMQ broker, that's very easy because there's a lot of stuff gets auto-configured, and then you put an event handler annotation on your methods, and it pretty much magically routes the events to appropriate methods. So if you receive a session started event, you can expect this method to be called whenever the event is received. As simple as that. But let's see how much work would need to be done in order to actually have the same functionality done, but without the framework itself. So I can imagine that an event handler underneath, somewhere in there, somewhere in internals, it's effectively just a map. It's a map that can route to different methods depending on something coming from a message. So let's create an interface that returns the routing configuration. That's not very difficult. Then you can create your own routing configuration, which is a bit verbose because you need to manually provide the types of those class, unfortunately, because that's how Java works. But it's not a big of a hassle. And you can test all of that very quickly because you don't need a huge application context running in your background for the integration tests to kick in. You can test it unit test very, very super fast. OK, that works. And the whole routing logic is effectively just checking if receiving a message, and once the message is received, you check if the route is in the configuration. If yes, you call the method. If not, you don't. That's pretty much all. And once we made it work, now we could implement a very simple Kafka event listener, which would just read messages from Kafka and pass the messages straight to our event listener, which was generic. Same you could do for RabbitMQ. A bit more code, but at the end of the day, it's just something that receives the message by yourself and uses the same infrastructure here throughout the message. And that's pretty much all. And the cool part of that is that using multiple string profiles, we could have it running alongside. So we knew that we made it work. It worked in a below 1 day, but we knew that we won't migrate that fast to Kafka. So we had 2 string profiles where we could switch in between very easily. So once the Kafka is there, we switch the profile and it works. I hope it happens one day. However, it wasn't a lot of work, but from the point of view of long-term maintenance, it's a huge upgrade because we were able to kind of bypass the problems imposed by the framework pretty much by writing not that much of our own code. Obviously, that's a kind of a hacky solution to the problem that long time ago, when the technical decision was made to use one particular framework, no one actually had a look at trade-offs involved in that and how this would fit in that particular context.
Yeah. How often do you switch Rabbit to Kafka? That's always a question I have in such situations. But on the other hand, yeah, that
I know what you're trying to say. I think the problem is totally in a totally different place. I believe that a few years ago, someone should have put, a big blackboard and put things in there. What we have, what we don't have, what are potential problems, what might be problems in the future, and make a conscious choice if this is a problematic or not, and accept or reject certain trade-offs. This is the missing part here.
Yeah, I think that goes to all the frameworks. That if you say we will use Hibernate for everything, sooner or later, usually sooner, it will bite you in the back. If you say, like in the example you did describing, you will use Oxen for everything, then you will get to a point where you don't want to use Oxen, and it will become problematic. If you say we want to use Rabbit for everything, it might be fine. But so on one hand, what you're trying to do in here, to my understanding, is that you try to abstract the implementation, the infrastructure being an implementation detail, right?
Yep. But obviously, I wouldn't recommend doing this to anyone if you start from scratch. Don't copy this code. Don't try to reproduce that. Just try to think in the long term. Maybe those problems caused by the fact that you can't switch from Rabbit to Kafka is not really a problem for you. So don't try to pre-optimize unnecessarily. And to be honest, this was a hacky solution to a problem of a legacy version of a framework. And as far as I'm concerned, I remember that Spring Cloud Stream provides you pretty much same functionality out of the box.
Approaching the end of.
What did I just say?
No. It's like that was a glitch. Sorry. We'll cut it off in the post-production. No worries. Sorry for that. You were talking about that this situation was a remedy for a legacy framework, for not, to be honest, not upgraded framework.
So nowadays, after having those many years of those frameworks to actually develop, I wouldn't envision this being a problem anyway. So definitely don't copy paste this. Don't try to repeat it mindlessly, because probably nowadays it doesn't make sense.
Alexander has a comment on that when you're going to write an application which is going to last longer than 1 year, there's a big chance that you will replace one library framework with something else. And yes, that's exactly true. But the thing is that once we design the application, and knowing a bit of a context that Grzegorz was describing here, once these particular decisions were made, this lifespan or this timeline is totally not understandable. I think hardly anybody thinks about architecture decisions in a way that, well, let's think how it look like in like 5 years, and is my application still going to be online after 5 years? And that might be one of the root source of the problem, like either using too much of a framework or using too little of a framework.
There is one comment from Jarek. These are very basic things that we are talking about since 90s. Exactly this one. So my personal thoughts on the subject are that at least Poland, if you are thinking about our local environment, has been treated a lot as a place where you outsource software for a very long time. Often not the software that local people somewhere else wouldn't write, but often commodity software, where the goal was to kind of save money and get something working. And I believe that probably there like huge part of the market of developers be working in outsourcing know how it feels like, that you just need to deliver something as quickly as possible. And if the client didn't request long-term maintainability, they get, does the basic set of features that allow you to tick the checkbox and get another deal. I believe this is a huge part that contributed somehow to the fact that we kind of forget about all of that. Because for some point, it doesn't matter. Our projects, they don't have long time spans. And often we don't need to work with the consequences of our choices. So I spoke with people, that have been working on projects, in-house projects, the software that needed to maintain business processes in their companies. And the approach and the mindset is a bit different than from software shops. And I've worked in a software shops before, and I know, and I went through like 6 or 7 projects during 4 years. And in most cases, the goal was to, make it work as fast as possible, but not really think about long-term issues. The funny thing is that some companies were actually calling us to get something done really fast. But there was another set of companies calling us, to help fix the maintainability issues caused by someone delivering stuff fast.
I remember I once seen a job ad that the recruiter was advertising that you will be doing only greenfield projects and whatever libraries and the set of frameworks of your choice, and you will never ever have to maintain anything. It's like developers heaven when you have like 3 years of experience, but then you just notice that you are clearly lacking something. So I've put it one of the final slides because we steadily get into the not the end of the conversation, the end of the presentation that Greg has given. We can go on and on for hours probably, but before we get to the end, and just to give people one more opportunity to ask questions, you did quite excessive, I won't say rant, but elaboration on frameworks and disadvantages and so on, and on opinions that certain frameworks impose on the developer. Is there other way around? Are there any frameworks or libraries that are not too opinionated and can give you this flexibility or this feeling that you are still in charge and you can do whatever you want with the set of stuff that you are given?
Naturally, although it's not that popular in our Java space. So besides those tools that I mentioned already that are used for persistence, if you are looking for something that would probably replace a Spring or some other framework like that, probably Ratpack is worth looking at, which is more or less just a collection of tools working together where you get a lot of power over to configure stuff the way you want. Personally, I would say it's really cool for small applications because you can start your server in the main public static void main methods, define controllers in there and pretty much all the stuff, and it starts very fast and it's very easy to configure without all that luggage that bigger solutions do have. I would say that Spring by itself, although I've been using it a lot as an example, is not that bad if used properly. So I'm not one of those people ranting on Spring. So I really like it after figuring out how to work with it properly. And those ideas that I showed you, those are not stuff that I came up with. Some of them actually come directly from Spring people themselves. When it comes to frameworks and tools that I'm quite interested in, I really like Quarkus. I will mention it mostly because Spring dominated the Java space, but there are new modern alternatives popping up. And the cool part about Quarkus is that it kind of doesn't really need to deal with all the luggage, all the legacy. They started building it from scratch to be container friendly and GraalVM friendly. So you get, they included even in the framework itself Maven plugins that actually help you generate Docker images, that help you build native images from GraalVM. They introduced the first build time initialization, which is actually a set of Maven plugins that run some code during build time, record the bytecode only so that they can replay it. They can start an application from the time the exact time where the bytecode was recorded, which means you just shovel off a few milliseconds or seconds of your startup time.
I think that's magic.
That's magic, yeah. That's also, but this is not kind of a magic that you need to often worry about. But what you need to worry about when it comes, that's what I forgot about to say. A new problem when it comes to classpath scanning popped up recently once people started playing around with GraalVM. Because let's be honest, if you take a average application, probably it won't be GraalVM compatible out of the box. So the GraalVM people came up with a set of tools that allow you to make substitutions of the code, which effectively means take the original code and substitute it to the code you wrote to patch it. And the way they are discovered is that there is some form of classpath scanning happening. They look for classes with certain conventions, having certain annotations. And what can happen from time to time is that if you... could you hear me?
Yeah, it's fine.
Okay. Because my headphones connected to a phone and someone called me, which shut off the feedback. Anyway. So nowadays, sometimes some libraries started shipping their own GraalVM substitutions with themselves. And suddenly you end up having on ClassPath multiple sets of substitutions for GraalVM, which creates even more ambiguity because it can patch the code using a different substitution, different patch that you think it would. So this is kind of funny stuff.
Somebody posted a comment. I'll put it over here that maybe, and yeah, that's something I personally can relate to. That in all this frameworkish, library-ish stuff, there are some basics that we like. The things you describe with all this magic and class path optimization and so on, sometimes is the end result when we want something that we already shipped go faster. But when we do start, we have this, or maybe we are lacking this try to prototype with just interfaces, with fake implementation, with just no I/O dependencies, to create a simple code that will show our intent And then as we grow, we replace bits and pieces with something that's really needed in situation when it's really needed. So
I fully agree with that. So imagine a simple example. For example, you need to develop a new service to, let's say, CRUD, a simple CRUD service that exposes some data to another team maintaining a different microservice. So what people usually would do, they would start with Spring. They would add a lot of auto-configs, auto-dependencies to make it, start up magically and start playing with that. But if we take a step back and recall the basics, what we could start with is a simple idea from a clean architecture. You put an interface between your, that represents some source of data that provides you, let's say, user data. You don't care. It's a abstract source of, let's say, users or some other user data. At this point in time, you don't need to care about where does it come from. Does it come from a database? Does it come from a NoSQL database? Does it come from another microservice? Doesn't matter. It's just an interface returning, let's say, users. And once you have this interface and to go to production fast, you don't need to play around with auto configuration and other stuff. You create a stub implementation consisting basically of concurrent hash map or something else, and you go to production immediately in a lightweight, easy to test form. Keep in mind that once the project matures and develops, then you can easily switch to something else. So as you said earlier, people usually mention is how often do I migrate from Postgres to MySQL or something else. This is mostly at the development stage where your application matures. This is where it's helpful. It's also much easier to test because if you start with clean on interfaces, it actually forces you to do TDD properly. One of the biggest confusions that people get about TDD is that you're doing trainings or something. People ask how I'm supposed to write the test first if I don't have a code to test. If you have interfaces and clear, like explicit encapsulation, you can do this. You can do this. You write your test because you know that from this interface there will be users coming, and you don't need to mock anything. You don't need to do anything. You express the intent. From this interface there are users coming. From this are messages coming, and then you test, and then you fill up the missing details. Of course, if you start from the other side, if you don't do that, you are starting writing infrastructure code that actually you can't really test until something is there.
That was one of my points on the list to tackle, but it'll probably make another hour of a conversation. Is that when you start testing and you just do the units and they grow, it's all great, but I see people forget to do this whole big end-to-end from time to time, or at least once, to see that all the stuff is really working. But on the other hand, when people start outside in, they have this big chunk that everything is really working, but only on the happy path. So, as you said, this reversing this cleaner approach just lets you focus on bits that you are really working on and TDD around them, just building interfaces, making it, red, green, compile. Red, green, compile, yeah. Red, green, refactor, yeah. Anyway, so I'm having a quick look on the questions. There are a few people teasing with us about dependencies and test dependencies and so on. But I think I'll call it a day. That was a great conversation with you. I think we should do it more often. At least I greatly enjoyed. Hope you meaning people on the other side of the screen, and you, Greg, as well, enjoyed. And it wasn't that bad to watch yourself on the video.
It was okay. So we need to wait until I make another presentation so that we can have it recorded and then replay it and comment again.
Yes, we can make it on the regular.
I have an idea. What if we record this one and react to this one? again.
I think we can. I know at least 3 people who will be enjoying watching this live and commenting, probably without muting, and it will be more like a stand-up, and they will be making fun of us, which is another way of doing it. Fair enough. It's another well, another idea. Anyway, if you enjoy, you mean participants enjoy this kind of format, or if you watch it later on YouTube and enjoy it, we have more of this to come, which is ideal for this pandemic times when we cannot go. We already missed so many great conferences because of the lockdown. So this is a way for us nerds to interact with each other. We have more to come if you would like to explore some further ideas of this kind of an online conversation over a presentation. We have a few on the link below. Well, below it's you, Greg, but below Greg. And on my left hand side, on right hand side, on that side, you have link to the presentation that Greg did and Twitter handle for him to him if you would like to continue. Any comment to add, Greg, at the end?
So thank you for staying with us. I hope you learned something, and see you soon.
Yeah, I enjoyed it as well. Thank you very much. Thank you, Greg, and thank you all. I hope we'll see each other soon. Thank you very much.
Thank you. See ya.